We're finishing up our unit on probability with 16.5 on conditional probability. It says that given the events A and B, conditional probability is the probability of B occurring knowing that A has already occurred. Okay, so we have talked about this in the last lesson here. The notation is the probability of B given A. The difference is that in the last lesson, we were just pulling things out of a deck of cards or a bag, and so we could just count down to find our adjusted probability. But sometimes you can't just count down like we did in the last time. Sometimes you have to use a formula, and that formula is the probability of B and A occurring divided by the probability of just A occurring. Okay? So on our Delta Math, we're not going to do any story problems or anything like that. So we're actually going to skip example 1 and 2 and jump down to where it says two-way tables. Okay, so a table that records data that pertains to two different categories is a two-way table. So if we're looking at this example here, example 3, a table shows the results of a poll that randomly selected juniors and seniors who were asked if they attended prom. So we've got two different categories. We've got their class, whether they're juniors or seniors, and then whether they went to prom, yes or no. So using this table, we've got to find our probabilities here. Now, the important thing about probabilities is we're always going to need like some sort of a total, right? So some tables give you the totals and other tables don't. This table actually doesn't give us the total. So we need to find all of our totals here. And to do that, it's pretty simple. We're just going to add our numbers up and then that'll give us our totals. So we need to add up all of our numbers, but we need to do it both ways. What I mean by that is we need to find a total of those who said yes, total of those who say no, but we also need a total amount of juniors and a total amount of seniors. And then we're also going to have a total here, which is all of those numbers added together. Okay, so let's take a look at that. We've got 28 plus 97. It's going to give us 125, which means 125 people did go to prom. Likewise, we've got 56 plus 19, which is going to give us 75. So 75 people didn't go to prom. Then if we're adding up our juniors, we've got 28 plus 56, which is 84. So we've got 84 different juniors. And if we're adding up our seniors, 97 plus 19, which is 116. Now that we have those totals, if we add 125 plus 75, we get 200. Also, if we add 84 plus 116, we also get 200. Or if we were to add up all four of these boxes, we'd also get 200. So there's lots of ways to get that number, but that is the total amount of people that were surveyed in this poll. Okay? So using this completed table now, what is the probability that junior did not attend prom? So a junior did not attend prom. We need to find the overlap there. So a junior and didn't attend prom. Those overlap right here at 56. 56 out of our 200 students that were asked. And that's going to simplify down to 7 over 25. Now that's not really a conditional probability, that's just a probability because it doesn't have the condition. It doesn't have that line like this did up here, right? The B given A, that was just a normal probability. That's why we did it over the total amount of students. These next examples do have this line here, so these are going to be conditional probabilities, okay? So what is the probability that a student did not attend prom given they're a senior? So if we look up at our formula here, we need to find the probability of B and A occurring. So the probability that they did not attend a prom and they're a senior. And we need to put it over the probability of the second one, which is being a senior. So the probability of not attending prom and being a senior, so no prom and senior, is 19. So 19 is going to be our top number. And then on the bottom, just the probability of A, or the second one, the total amount of seniors. Total amount of seniors is 116. So we've got 19 or 116. Okay. Now, the probability of being a junior given you attended prom. So probability of both being a junior and went to prom is 28. And then over the probability of just the second one, or just those who attended prom, which all those who attended prom, 125. So we've got 28 over 125. Now, sometimes it'll specifically ask you to fill in the chart. Like in the last one, it didn't ask us to fill in our table, but we still needed those values. So that's why I filled it out. Sometimes it's specifically going to ask you to fill out that table. And we're just going to do exactly what we did before. So down here, we're doing students who play an instrument or not and play a sport or not. So all those, the total amount that play an instrument would be 9 plus 14, which is 23. The total amount of people who don't play an instrument would be 33 plus 19, which is 52. Total amount of people that play a sport is 9 plus 33, which is 42. And total amount of people that don't play a sport is 14 plus 19, which is 33. And then however I want to count that up, I've got 23 plus 52 or 42 plus 33. Either way, 75 is my total amount of people. And now it's just going to ask me questions about this chart. How many students play an instrument? Well, I will go to play an instrument. How many total are there? 23. How many students play an instrument and a sport? Okay, well, play an instrument and a sport, there's 9 of them. That's where they overlap. How many students do not play a sport? Do not play a sport. We got a total of 33. How many students play a sport but do not play an instrument? So play a sport, do not play an instrument, 33. And how many total students were surveyed? That'd be my grand total down here, 75. Okay, so that didn't ask about probability at all. It just asks for information from our tables. Okay, let's do one more example here. This one doesn't give us any information in our table, but it does give us information in this paragraph. Okay, so Sydney randomly surveyed students at her school and found that 72 students ride the bus and 37 of those students buy lunch from the cafeteria. Okay, so the total amount of students that ride the bus is 72. So I'm going to go to ride the bus. The total is 72. And then of those 72, we've got 37 of them that buy a lunch. So 37 buy a lunch. The next sentence says there are 19 students that do not ride the bus, but they buy a lunch from the cafeteria. So do not ride the bus, but buy a lunch is 19. And 9 students do not ride the bus or buy a lunch from the cafeteria. Okay, so that would be right here. Now that is all the information it gives us, but that is enough information to fill out the rest of this chart. If I was trying to find those who ride the bus but do not buy lunch from the cafeteria, well, I've got this number and this number, so I can actually do my total, 72, subtract 37, and I'll find my missing value. 72 subtract 37 is 35. And now I've got those 4 main ones filled in, so I can just find my totals how I have been. My total amount that does not ride the bus would be 19 plus 9, which is 28. Total amount that buys the lunch is 37 plus 19, which is 56. And total amount that does not buy a lunch is 35 plus 9, which is 44. And then if I added those numbers together, I'd get 100 as my grand total. Now I'm just going to answer these questions. How many students buy their lunch? Well, I've got a total of 56 that buy a lunch. How many students ride the bus but do not buy their lunch? Well, if I look at that box, I've got 35. How many students do not ride the bus? I've got a total of 28 that do not ride the bus. How many students do not buy their lunch? Do not buy their lunch. I've got a total of 44 students. And how many total students were surveyed? That's my bottom right corner. 100 students were surveyed. Okay, that is the end of notes today. We have a partner practice down here on page, let's see, 20. It is only example 9. Complete example 9 with your partner and then come get a stamp. And then we'll work on Delta Math.